Dear students, let's start with the topic of electric current. And in your early classes, you might have studied about the basic definition of current, in which we write that rate of flow of charge through any cross section of a conductor in which current is flowing, obviously we are talking about, is called electric current. To understand the basic analysis of current in various circuits, here you can have a look on the situation. When we are given with a cylindrical conductor connected via perfectly conducting wires with a battery and a switch. Here you can see when we close down the switch, positive terminal of battery will pull free electrons of the conductor, which will start flowing through the wires in anti-clockwise manner, and a continuous flow of electrons exists, and in the process of current flow, battery has to do a continuous work, or we can say battery has to supply a power, that is work per unit time, to maintain the current in the circuit. And due to these flow of electrons, we can say a current exists in the circuit in clockwise manner, because conventionally you know that the direction of current flow is opposite to the flow of electrons, or direction of flow of current is considered as the direction of flow of positive charges. That is a convention we use. Now, if we just talk about the magnitude of current, this can be written as rate of flow of charge delta Q by delta T. If delta Q amount of charge is flown through any cross section in a time delta T. Say if we can say if n electrons pass through a section in time delta T, then here we can state charge flowing can be written as NE, where E is the charge of electron and N are the total number of electrons which passed through a given section. Then I can be written as NE by delta T. Or for a continuous flow of charge, this current can be written as dQ by dt, which we can also term as instantaneous current. In the situation where the rate of flow of charge is not constant, it is varying, we always define instantaneous current, and the whole analysis related to current is done by this time derivative of charge flowing in the conductor in which we are calculating the current.